Hello guys, and welcome to the fourth lesson of Motion Design course. Today we are going to talk about one of the most important things in animation, easings. We will learn its types, how to define bad and good easings, and of course we will decide which graphs to use, value or speed. Let's make it clear and I will explain everything with examples. Open the attached keyframes After Effects project. There are represented all main types of keyframes with their speed graphs in this composition. Let's have a detailed look at each of them. We will start from the standard rhombic keyframe. It's linear. This keyframe, if we are talking about the position, creates transition between two states with constant speed. You can see that by its rectangular speed graph. Just to make sure, open the graph editor of this layer. If you have another graph displayed in editor, right-click on empty place and select Edit Speed Graph. It's important to understand that linear movement can be hardly ever met in real life, so please don't use it often in your animation. Movement based on toggle-hold keyframe principle can be met in real life even more rarely than linear. It is an instantaneous change of value. After Effects doesn't create any in-between frames between these keyframes. The object is in one place and at once teleports to another. That's all. The most popular keyframe type is Easy Ease. Just press F9 or function F9 if you're on Mac to turn linear keyframe to Easy Ease. Its type of keyframe has a form of sandglass, and its speed graph has a form of parabola. That means that its speed smoothly rises from the start, reaches the maximum in the middle, and smoothly slows down in the end. Of course, this type of easings is not so often used in its default form, but still we highly recommend you, whatever you're animating, at least convert linear keyframes to this type. It's also a pretty common situation when we want the object to move with increasing or decreasing speed. Ease out and ease in easings will help us in this case. To apply them, just select keyframes, right-click and Keyframe Assistant and select one of them, or just use relevant hotkeys. The next type of keyframes is very helpful in animating position property. It calls Rove Across Time. It's pretty easy to understand how it works. Imagine the situation when you have to animate the object's position property along a complicated path, which can be recreated only with two keyframes. And the easing should be one for the whole path. Of course, you can spend a lot of time and try to align multiple speed graphs in one general. But you don't have to do so with Rove Across Time. It turns all selected keyframes except first one and the last one to in-betweens. They will be automatically distributed on a timeline between two main keyframes and automatically adjusted to the speed graph. And the last keyframe type is called Linear Continuous. The main feature of this type is that it joins two speed graphs. For example, I have the animation created with 3 keyframes, and I want to increase the speed in this one. If I go to Graph Editor and start adjusting its position, it will split in 2 points. But after the conversion of the keyframe to Linear Continuous, you can do this by clicking on a keyframe with Holded Ctrl. The graph won't be cut in the middle, it will be editable as one point of graph. You also can convert the keyframe to Linear Continuous directly from Graph Editor. For that, right-click on a point, Keyframe Velocity, and check the continuous lock in this window. Now let's talk about Graph Editor. There are 2 types of graphs inside After Effects, value and speed graph. Let's start from the first, value graph. It shows the dependence of value from time. So by editing this curve, you can control the value over time. It's pretty useful because it's vivid. For example, we're animating the fall of this ball. Go to Graph Editor and it's necessary to separate dimensions. So here is horizontal axis, it's time, and vertical, it's value. Let's make it bouncing from floor. For that, I will add 2 points on a graph, so 2 keyframes will be added automatically, and make the curve of this form. The higher curve is, the higher ball jumps. Very vivid. But what if we need to create more complicated animation or animation of path? For example, we want to make the ball jump over this box. So we built our motion path, and easing is not okay. The movement is very flat. Movement needs to start very fast, then smoothly slow down, and then accelerate again. And motion path should stay the same. Here, suffering begins. Because each hour adjusting a value graph influences motion path, not speed. And we also need to edit graph for each parameter separately. And it's crazy routine. So now let's have a look at speed graph. This graph shows the dependence of speed from time. It doesn't have the problem with complicated motion paths as value graph has, because it influences only on speed of movement. No matter what trajectory you draw, it will save it. The frames will be distributed along this path. For example, we have such animation. These points illustrate the object's position on each frame. So select all keyframes and press F9. As you can see, frames have redistributed and the path is the same. Go to Graph Editor. Everything is pretty easy to understand. The speed increases to maximum and then decreases. We can edit a graph this way to make the animation have more interesting speed. Ha, nice! But let's have a look at what's going on in value graph. Well, not so obvious. And in case we want to edit this graph, it will influence the form of motion path. But we don't need that. So what are the bad points of the speed graph? The only thing, it's an unusual principle of editing Bezier points. Unfortunately, you're able to edit direction lines in two directions, rightwards and leftwards. So you will have to be patient and get used to this graph. Let's sum up all information and determine in which cases we have to use each type of graphs. Value graph is useful with one-dimension properties, for example rotation or opacity. By dragging the direction lines, you can achieve really good results. It's also pretty easy to manually create bounces using this type of graph. Speed graph can be used in all other situations. In most cases we can do make with this graph, but you will have to get used to its interface and understand the object speed in different situations. Let's get started with practice. Try to recreate this pendulum animation without our help, but if it seems impossible to you, draw a straight line and a circle on a single layer. Replace its anchor point to the top. Pendulum swings from side to side, so we will animate rotation property. Rotate it this way on the first frame, then move to 1 second and change its value to opposite. Go to 2 seconds and paste the first keyframe. Make a work area 2 seconds long. And let's play the animation. Very flatly, because at the moment all movements are linear. To make it better, let's understand the pendulum movement. It reaches the maximum speed in the middle of its oscillations. Here. Then it slows down in its extreme point, and then again speeds up under the influence of gravity. Select all keyframes, press F9 so that we made the keyframes easy ease, and make a preview. And that's better, but not good enough. Open the speed graph and you'll see that its maximum speed is in the center of oscillation, where it needs to be, but there are no noticeable slowdowns. Adjust the graph this way, so that we created these areas where speed is changing very smooth. They make slowdowns. Preview, and it's done. Now draw the ball with the ellipse tool. Let's make a glare with dashes and trim paths. For that, make a duplicate inside shape layer and remove fill. Set up stroke. Decrease its size. Make a dash line. And add trim paths. Trim the line. And make it a little transparent. Place the anchor point to the bottom of the ball. Now open up the position and scale properties. We will animate them. Let's start from position. We are creating a loop and will start from the upper position of the ball. For that, make a keyframe on the start of timeline and place the ball this way, in the highest position of its jump. Then go to a half of a second and place the ball lower, to its hidden position. And on the time of 1 second, paste the first keyframe. Preview the animation. It's not good. Let's change it. Select the position keyframes and press F9 to easy ease them. And go to Graph Editor. we will work with the speed graph. Now let's think what's happening to the ball during its movement. In the very beginning it has the almost zero speed, which then smoothly increases and becomes maximum in the moment before hitting the trampoline. Then happens the hit and reflection of speed in opposite direction. The ball is continuing its movement to the highest point and freezes in the air for one moment, and then started falling again. So let's make it on the speed graph. Move the direction line of the first point to the right, so that we did smooth speed increasing, and make the same actions in opposite direction with the second extreme point. Make a preview. It's better, but the pause in the moment of hit should be smaller, because trampoline pushes the ball faster, so adjust the graph in following way. Now the pause is smaller. Make a preview, and it's much better now. So we're animating the ball and there is no squash and stretch at the moment. Let's create it by animating scale property. On the first frame, when the ball is in its highest position, leave the value of 100, since almost no forces affect the ball. Maximum speed is reached in the moment before hit. So move to 2 frames before hit, switch off dimensions dependency, and stretch our ball. The important thing while animating scale property is that ball should have the same volume during its movement. So if we increase the one parameter of scale by 20%, we have to decrease another by the same value. The maximum squash must be in the moment of hit. Change to 120 and 80. And after the hit, speed is reflecting in opposite direction. And the ball stretches under the influence of this force. So 2 keyframes after the hit we need to stretch the ball. And another extreme point, 100, 100. So we're almost done. Everything looks much better, but let's create easings for scale properties. During ball movement from its highest position to lowest, speed smoothly increasing, so the transition graph between circular and stretch states should have a similar look to position following graph. So select the extreme points and grab them in this way. Be careful, we have to edit 2 graphs as property consists of 2 values, and make the same thing with the second extreme point. Play the animation, and it's look really good. Now let's create a trampoline. Select the pen tool and draw the straight line. Set up the color and create a new vertex in the center of line. Smooth it. Round the line caps. And draw the leg. Now let's animate trampoline reaction on the hit. Unfortunately, bounce expression can't be applied to path property, so we have to do that manually. Move trampoline upper, move to 2 frames before the hit, and make a keyframe on the path property of trampoline. In the moment of hit, arc the trampoline this way. Now 2 frames further, and arc the trampoline in opposite direction. Let's make a few oscillations and decrease the amplitude with each next keyframe, and the last 2 we will make with a larger interval to make them fade. Now easy the keyframes by pressing F9 and make a preview. Looks pretty nice. And animate the leg. We will also animate its path properties in the same time with trampoline distortions. Make a copy of leg, reflect it horizontally, and place it to the right position. Make a preview. Really nice. As you can see, everything is not so hard when you have a clear understanding of the movement you are animating. You will have to practice a lot with speed graphs while working on your homework. In the simple homework, you'll need to animate the ball jumping on the stairs. The principle is the same with trampoline, but with a little more complicated motion path. And for those who want to go deeper in easings and become a real master, we propose to play a game. We prepared for you the special After Effects project with Kingdom Motion Pinball Machine. Your task is to animate the ball as natural as possible and get the highest score. There are two compositions in the project. Animate. In this one you will create animation, and Render, which you will need to render. You also can animate flippers in Animate composition, and it will automatically appear in Render. So it's all for now. Good luck guys, and see you on the next lesson.